Right, let's have a look at one more example of differentiating the natural log function. So we have to differentiate the natural log of the square root of x. So it looks very awkward, but it's actually quite simple. We're going to use the chain rule because we've got two functions here combined together. We've got the first function is the square root of x, and the second function is the natural log function. So let's start off by writing f of x is equal to ln the square root of x. So our first function, let's call it u of x, is equal to the square root of x. And our second function, let's call it v of x, is the natural log of the square root of x, or the natural log of u of x. So both of these are easy to differentiate. So u dash x, okay, well actually, first of all, before we differentiate the square root of x, we should remember that we have to write it as x to the power of a half. So u of x, instead of the square root of x, I'm going to write that as x to the power of a half. And now it's easy to differentiate using the x to the power of n rule. If you remember, when I differentiate something that looks like x to the power of n, so x to the power of a half, I get n x to the power of n minus 1. So differentiate x to the power of a half. So u dash x will be equal to a half x to the power of a half minus 1. So I guess, tidy that up, a half x to the power of minus a half. Now remember what to the power of a negative number means. It just means, well, if you've got, let's say, a to the power of minus n, that's the same as 1 over a to the power of n. So x to the power of minus a half would be 1 over x to the power of a half. And anything to the power of a half is just the square root. So I have 1 over 2 times 1 over the square root of x, or 1 over 2 root x. So let's have a look at that again. So when I differentiate x, the square root of x, before I differentiate it, I write it as x to the power of half. And when I differentiate it, I get this. But I just tidied it up and I wrote it like this, 1 over 2 root x. So, okay, let's go back to the second part. So I need to find v dash x. So differentiate a log function. Well, log function, the natural log function, when I differentiate ln x, I get 1 over x. So when I differentiate the natural log of u of x, I get 1 over u of x. But u of x is just the square root of x. So I get 1 over the square root of x. So then by the chain rule, I have f dash x is equal to u dash x times v dash x. The two functions differentiated, multiplied together. So I have u dash x was this bit down here, 1 over twice the square root of x, times v dash x, which is 1 over the square root of x. So times 1 over the square root of x. And this one turns out nicely. I've got top by top. So 1 by 1 gives me 1. And then 2 root x by root x. Well, root x by root x is just x. So 2 root x by root x will just give me 2x. So when I differentiate, I get 1 over 2x. So differentiate the natural log of the square root of x, I get 1 over 2x.